The lab for this week was about the charge tape lab revisited. The purpose of the lab was to model the tape to be several point charges in a line for a more accurate model of electric fields and forces. Concepts used within the lab are Newton's third law, superposition of charges, and charge distribution. Several equations were used within this lab. The first is Fg equals ma, which is the force of gravity. E equals kq over r squared times r hat, which is the electric field equation. And then Fe equals QE, which is the electric force equation. For this lab, the system included the tape strip, and then everything else was included in the surroundings. Here is the code used to create the model. The top left is initializing variables and the electric field. The right is setting up the forces between the two tapes. Bottom left is setting up the different arrows to actually model it, and then the bottom right is also setting up the model. And then here's the actual model. Some assumptions are that the charges from the tape are equal on each other, and the total charge from the tape is the sum of the charges from each point that was created. Different potential sources for error is that air resistance and potential air currents added, extra force that electric force and or gravitational force needed to overcome to reach an F net of 0, and then electric fields coming off of your hand affecting the tape, or the electric charge dissipating off the tape into your hand. Why do the values of the labs differ from each other? The line charge model is more accurate to what the real life scenario is, rather than modeling the scenario using a single point. And then what if both tapes were modeled as points like in the first lab? If the tapes were modeled as points, the result would be a relatively good estimate, but nowhere near as accurate as if it were to be modeled like it was.